Hi friends, welcome to follow up. Minutes ago we have seen problem 63 unique path 2. So that's a daily challenge problem. So this problem 62 unique path. So we can regard it as unique path 1. So it's a similar problem or it's closely related. So here this one is easier than that one. So we want to make some practice. So here we are going to use dynamic programming to solve this problem. So here we have a robot on the M by N grid. The robot is initially located at top left corner, and the robot tries to move to the bottom right corner. And the robot can only move either down or right at any point in time. So here, given two integers M and N, so we want to return the number of possible unique paths that the robot can take to reach the bottom right corner. So here we have two examples. Given the 3 by 7 grid, so there are 28 ways. And given 3 by 2, there are 3 ways. So in the example 2, it lists all the possibilities. So here the constraints are the following. So the two sizes, M and N, in other words, the number of rows and columns respectively, they are both bounded above by 100. In other words, the problem size is not very large. So with that said, basically we can do the coding directly. So here our strategy is nothing but dynamic programming. So this problem logic is very straightforward, so we just need to translate the problem into code. So first, I'm going to initialize a DP table. So here we are in 0 for a dummy index in range M. So this DP table is a M by N grid. So here we use 0 as the initial value for each cell, right? And then what we are going to do, so here let's write with some details so that we can make the logic clear. First, dp00, so we're going to set it to be 1, right? So in other words, we want to interpret dpij to be the number of unique passes passing through that position. So here the main assumption is that the robot can only move either downwards or rightwards or to the right, right? So this is the one. Next, actually we can set and initialize the DP table for first row and first column and then do the update. So let's write with some detail. Let's first set the first row, right? Then basically for j in range, so 1 to n, right? So notice that we have set the 0, 0 position. In other words, the top left corner. And then we iterate j. You can regard j as a column index from 1 and ending at n minus 1, right? So first, this one, so because all this row it should be 1, so actually we just need to set dp 0j to be 1, right? And similarly, we can set the first row, the first column. So because there's only one possibility, so we are going to do this for I in range 1 to m, right? So we want to set dpi 0 to be 1. So once we do this, actually we can do the setup for the generic cells and then do the update. So for I in range, so we can iterate from 1 to m. So for j in range, so 1 to n, right? So for each position, we can arrive that position from the top, from above or from left, right? It means dpij. So it's the sum of dp I minus 1j. So this means we arrive at ij from I minus 1j. In other words, from the above. And then we are going to add dp I and j minus 1. In other words, we arrive at position ij from position I, j minus 1. In other words, from left, right? Then what we need to return is nothing but dp -1, -1, right? So this line of code explains or is in corresponding to the assumption that the robot can only move either down or right at any point in time. So with that said, basically let's finish the coding part. Let's first do a test. Yeah, it passes the first example. Now you can test some other configurations for M and N, right? So here let's directly test the generic case. Yeah, it passes all the cases. So for this problem, because the code is actually very straightforward, you can shrink the code or compactify the code in just in a double for loop. That will be very straightforward. So with that said, basically that's about it for this specific problem. So actually in leetcode, there's another problem that is unique path 3 actually. So it does not include in this part, but we are going to have a look at that problem next time. So with that said, that's it for this video. Thank you.